Hello everyone, welcome to another session of data structure. I hope this finds you in sound physical and mental health. So let's dive into today's lecture. Learning data structures through C, you have to learn four things or four topics before you actually delve into the data structures. These four topics are data, relationships, complexity analysis, and dynamic memory. So you'll be learning all of them one by one in separate videos. Today we'll be dealing with data. Okay, let's start. So today's agenda is first we'll be reviewing the earlier concepts, then we'll go for the classification of data structures again, then we'll revisit the data and we'll try to figure it out how it is represented in the memory along with the negative numbers, and finally we'll conclude this session. So let's start. So to start with, in our earlier class we learned about what is a data structure. Data structure is nothing but it's a building block of programming. It defines how data is organized and consequently how data is allocated in a computer memory. The importance of data structure for algorithm efficiency cannot be overemphasized. It means that until and unless you know why you are learning data structures, it is very evident to learn about data itself, because unless you know about your own data you won't be able to solve the problem with proper choice of data structure. That's what first point means. The efficiency of most algorithm is directly linked to the data structure choice. So if you don't know about the data itself, it would become quite difficult to choose a particular data structure for a particular set of problem. Secondly, the ADTs, that means the algorithm, which basically are data structure plus the operations associated with it. These implementation also needs a better understanding of data. And thirdly, for the same amount of data, different data structures can take more or less space. This actually deals with the complexity. So these were the earlier concepts that we have learned. We are revisiting the classification of data structures again because I have told you that this needs to be dealt in our later classes. So till now we already know what are the different classes of data structure. So we have learned that data structure are normally classified into two broad categories: primitive and non-primitive. See, primitive data structures are also known as built-in types. It means that the entities here, like integer, float, character, boolean, the machine already knows about it. It means that what is the range of entities and what are the operations allowed with this integer values or float values or character values, machine already knows. So primitive data structures are basic data structures and are directly operated upon by machine instructions. It does not need to be told what are the things needs to be done for integers or float, because you already know what are the operations allowed with integer. Then another kind of data structure is there, that is non-primitive. So non-primitive data structure are derived from primitive data structure, and actually they uh, emphasize on structuring of group of homogeneous or heterogeneous data items. So what actually it means is these are derived from primitive data structure, and this needs to be told clearly what are the different operations available and which data they will operate upon. So for example, if you look at array is a collection of homogeneous data items, where in some other languages there is another data structure known as a record, which act on heterogeneous data items. So you have to be very sure that for which kind of data what data structure should be chosen. Then see, a non-primitive data type is further divided into linear and non-linear data structure. So what is a linear data structure? So linear data structure, or a structure to be linear, has to follow the four following rules. So what are these rules? There is a unique first element, then there should be a unique last element, then every component has a unique predecessor, and every component has a unique successor. So what it means is, in a collection of data, there should be a unique first element, there should be unique last element, there should exist an element before an element, there should exist an element after an element. So these last two rules does not act upon the first element and the last element. So if any structure is following these four rules, then that structure is nothing but it's a linear structure or linear data structure. And if one or more of the above is not true, the structure is non-linear. You have another set of classification based on linear data structure. These are direct versus sequential, and it actually depends upon the accessing of the stored data. So you can see in any linear data structure, we have two methods of accessing the stored data. These two methods are sequential and direct. So what is a sequential? Sequential structures are such that we can only access the nth element after we have accessed all the element in preceding n. What it means is if you want to access the last element, you have to access all the elements before the last. So what is an example for this? You can have a cassette. So to play the fourth song, you have to access the first three songs. So that is an example of sequential data structure. Sequential, as the name suggests. And in direct, it again is very literal to its name. Say it access the element of the structure without intervening any other element of the structure. That means any element of the structure can be accessed directly. There is no need to access any other object besides the element required. So what is an example of this? This is CD is an example. So this is direct and sequential. So up to this, we have already learned in our last class and we have just detailed it here. Now coming to next topic is knowing your data. So to understand this topic, so we'll start with writing a program to calculate the product of two numbers, namely A and B. So if you have to write a program to calculate the product of two numbers, so you first have to write the algorithm. So you can write the algorithm two ways. Either you draw the flowchart or you can write it in the pseudocode. So I've drawn the flowchart. So this is what the flowchart looks like. We declare three integers, which is A, B, and C, and then we read A and B, and after that we calculate the product of A and B and store it in C, and finally display C. So this is the algorithm, and I have converted this algorithm to a program. It looks like this. So I guess this is correct. So let's test this program. So to test this, I have used three test cases. So in the first case, I'll be providing AS10 and BS20. In the second case, I'll be providing AS100 and BS200. In the third case, I will be providing A100,000 and B200,000. So if you look very carefully, if I give the first case, I'm getting 200 as the product. Okay, let me see. This is the 200 product. So I guess the first test case is successfully executed. If you look at the second test case, now this time I have provided 100 and 200, and here the product what I am getting is correct. It is 20,000. Fine. Now come to the third one. When I provide 100,000 and 200,000, I am getting a product of A and B as minus 1474,836,480. So it's better that if you write this output in some copy, because it will be needed in our later slides. So the product of A and B, it is showing minus 1474836,480, but we know this product is not correct, because we already know it cannot be a negative number for 100,000 and 200,000. So why do you think this kind of anomaly is coming? What do you think could be the reason? Whether my program is incorrect? So can you guess it? So let's try to understand why is it happening. To understand why this kind of output is generated, even though we have given both the numbers as positive, we have to understand how machine communicates. See, machine can only communicate and understand machine language. That is either 0 or 1. This 0 or 1 is nothing but it's a bit. It is the basic unit of information computing and digital communication, and it's known as bit. And a bit represents a logical state with one of the two possible values. So what are these values? Let's suppose this uh, circle represents a bit. So it could represent one of the two values. So it can either represent 1 and 0, or true and false, or on and off. So it could be any value which exist only in two forms. It could be high voltage, low voltage also. So it depends on you. So we'll go with 1 0. So this is the memory capacity of a bit, or what is the, this is the terminology of the bit. See, 8 bits consist of 1 byte. 1024 byte is 1 kilobyte, 1024 kilobyte is 1 megabyte, and so on. So this chart I provided just to make you understand the terminology which we today in day-to-day life we use it in a very frequently. So how is it represented in the memory? So if I have 1 bit, so I have only 2 options. I can either fill it with a 0 or with a 1. Correct? Now if I have 2 bits, I have 4 options. I can fill both the bits with 00 or 01, 10, 11. 0 and 01 and 10 are two different things. So don't mix and match, because you might be thinking why 0 and 1. Here the order matters. So I have 4 options. If I have 3 bits, I have 8 options, 2 into 2 into 2. So if I follow this logic, so if I have n bits, I have 2 raised to n options. And this is a very simple mathematics. One more thing, that 1 byte is equal to 8 bits. We are very much interested in byte because actually when we say memory, we are talking about RAM. So RAM is segmented in byte wise, means each byte consists of 8 bits, and these 8 bits gets a address of its own. So how it is represented, how it will be represented in memory? For example, if I take I equal to 10, integer I equal to 10, if I give this command, then as per the modern CDA compiler, 4 bytes of memory will be allocated. 4 byte means if 1 byte is 8 bits, 4 byte means 32 bits. So 4 bytes will be allocated to 1010. Why 1010? Because at the end of the day, everything is converted to binary. So the binary equivalent of 10 is 1010. So that means we have already used 4 bits. So I am left with only 28 bits. So these 28 bits are filled up with zeros. So this it will look like, see, byte 1, it has 1010, and every other thing, every other byte has been filled up with zeros. So this is how it is represented in memory. So I am drawing a logical memory here, logical RAM memory. Don't confuse with the original RAM. Uh, so this is byte 1, byte 2, byte 3, byte 4, and each byte, as I've already told, has got a address of its own. So I'm giving some random addresses like 1001, 1002, 1003, and 1004 to byte 1, 2, 3, 4. Then there can be another arrangement. Look here, the byte 1 gets 1001. There could be another arrangement that byte 1 gets 1004, byte 2 gets 1003, byte 3 gets 1002, and byte 4 gets 1001. So the left hand side, this architecture is known as little endian, and the right hand side, this architecture is known as big endian. So we'll assume that we have a little endian architecture. We don't go into the details because this is out of the scope of this syllabus. So this you might have encountered in your digital communication or basic electronics. So next topic is integers not only hold positive numbers, it also holds negative numbers as well. So how do you think these negative numbers are represented? So these uses a concept of 2's complement to represent the number in binary system. Now what is a 2's complement? So to understand 2's complement, the steps of 2's complement, let's understand something else. For example, if there is an integer data type, I have total 32 bits. So, but if it is an integer negative number, then the most significant bit, that means the leftmost bit, is reserved for the sign. That is why it is known as sign bit or most significant bit. So I'm left with only 31 bits. So this will be this will decide the magnitude of the number. So 32 bits is divided in two parts. The leftmost bit or the most significant bit is the sign bit, reserved for the sign, and magnitude is 31 bits. The sign bit means if I have 1 here, then it will be negative. If I have 0, then it is a positive number. So let's go with 2's complement, the steps. The first step is find ones complement first. That means invert all ones to zeros and all zeros to ones. That means you convert all ones to zeros and all zeros to ones. And then you add 1 to the least significant bit. Now, as you have already encountered, most significant bit is the leftmost bit of any binary representation. So least significant bit is the rightmost bit of any binary representation. So here it is telling add 1 to the least significant bit of the given result will give us 2's complement. So whatever the result I get after one's complement, I have to add 1 to it, to the least significant bit, so as to get the 2's complement. For example, if we have already seen this is the representation of 10 in 32 bits. Now I have to find the ones complement first. So let's invert all the zeros to 1 and all the ones to zeros. It will look something like this. After that, you just have to add 1 to this number. Why? Because this is the least significant bit, the rightmost bit. And after adding 1, I'm getting something like this. If you try to find out what is its decimal equivalent, you will get it is minus 10. So this is how minus 10 is represented in the memory. This is how negative numbers are handled. So when we multiply 10,000 with 20,000, we get something like 20 into 10 raised to 9. In binary system, if you find the binary equivalent of this, you will find something like this, which is of 36 bits. But as we have already encountered that integer data type can only hold 4 bytes, that is 32 bits at a time. So these 4, the first 4 will be neglected, will be ignored, and the rest 32 bits will be the part of integer representation. These 32 bits is a part of integer representation, or the representation of the number which you have got. So this bit is already, we already know this is a sign bit because it's a 1, that means it's a minus, it's a negative, and remaining 31 bits are the magnitude. Now as we have magnitude here, so we also have to convert this magnitude into its proper form, that means we're using 2's complement. So if I use the 2's complement here, so first I have to find out what is the 1's complement. So we have found out what is the 1's complement here. You can check it out by practicing on your own, and then adding 1 to the least significant bit, then adding 1 to the least significant bit. So if you add 1 to least significant bit, you know how the addition works and you'll get this. Now you just copy this and then you go here and try to print calculator. See, this is the calculator, and check you are in the programmer mode or not. So you have already programmer mode. Now it has 4 different types of number system: hexadecimal, decimal, octal, and binary. So I have already copied the binary equivalent or the result of the 2's complement. So come to binary and paste your binary equivalent. So once you paste the binary equivalent, and if you go to dec, that is decimal, you will find that this is the magnitude you are getting: 1474836,480. If I'm not wrong, this is the same thing you got once you were here, once you have given 100,000, 200,000, and you have got 14744836480 and minus sign. So you have already know why this minus sign is coming. This minus sign is coming for sign bit, and this is the magnitude of the 2's complement, whatever the result we got after doing the 2's complement. So that is why this is giving this kind of result. So what we can do to solve this. What we can do to solve this. So what we can do is, instead of giving int, we can write long int, and instead of writing simply percentage d, you have to write lld. So you could see here, this is lld, and similarly lld could be given here as well as in the printf statement for the c. So once you give lld or long int and you try to run this program, so now if I give 100,000 as the first input and second input is 200,000, so this time I'm getting the correct result. You can see this. So this is how this thing can be solved. So thank you for your patience. We'll meet in our next class. Thank you everyone.